Okay, very good morning to all. So today we will be discussing about the force analysis of spur gear. So we will directly discuss a numerical. The pitch circles of a train of spur gear are as shown in the figure. So in the figure there are A, B, C, three gears are shown. Gear A receives 3.5 kilowatt of power at 700 RPM through its shaft and rotates in clockwise direction. So it is given in the figure also. It is rotating in clockwise direction. See here, the direction is given in clockwise direction. It is rotating. Okay, then gear B is the idler gear. Very important. Gear B is the idler gear. It is not transmitting any of the power to its shaft. It is just taking from A and giving to C. The number of teeth on while gear C is the driven gear. So this is the driver gear A and gear C is driven. So gear A is, I will write in this diagram only, driver, and this is nothing but the driven gear, and it is clear cut mention that gear B is the idler gear. The number of teeth on A, B, C are given. Module is also given. We have to calculate the torque on each gear shaft and the components of gear tooth forces. Components of gear tooth forces we have discussed in force analysis. This is nothing but the PT and PR, the tangential load and radial load. And we have also discussed about this, the tangential load, PT. It is always acting in the direction of driven and opposite to direction of driver. And PR is always acting, the radial force. It is nothing but the separating component. It is always acting toward the center of the pinion and gear. The same we will apply for A and B pair. Same we will apply for B and C pair. Draw a free body diagram of forces and determine the reaction on idler gear shaft. We have to determine the reaction, particularly idler gear means at this point, at this particular point, we have to determine the reaction idler gear shaft. Assume 20-degree involute system. So, draw the diagram and write down what is given. I will simultaneously write here. So, drawing diagram of is very important and it is given. So, gear A receives a power kilowatt is equal to 3.5 RPM 700 through its shaft. So, RPM. Okay, it is at gear A. Then we have written which is the driver, which is driven, and which is idler in the diagram only. The number of teeth. So here it is given A, B, C. So I will say here number of teeth on gear A. ZA is equal to 30. Respectively, it is mentioned. Number of teeth on gear B is equal to 60. And number of teeth on gear C is equal to 40. So number of teeth on each gear are given ZA 30, ZB 60 and ZC 40. The module is 5 millimeters. So we will assume the module as 5 millimeters. The module is 5 millimeters. Okay, next we have to draw a free body diagram. Assume 20-degree involute system. So alpha is given 20 degree. Alpha is given 20 degree in this case. And what is expected or required to calculate in this particular diagram? So in this case, I will say we have to calculate torque on each gear shaft. So I will simply say we have to calculate MT. So I will calculate MT for gear A, MT for B, and MT for C. Then component of gear tooth forces. So I have to calculate PT and PR, the tangential and radial component. So this is the first part. It is asked. This is the second part, and in the third part, we have to go for drawing a free body diagram, and we have to calculate the reaction at this particular gear. So I will call this reaction at this RB. So reaction as idler shaft is asked. Reaction on the idler gear shaft. So these three things we have to calculate, and this is the given thing. So take 1 or 2 minutes, then I will give you the step, and then we will move further for solving the numerical. Okay, so let us move further. I think that diagram is drawn. Just put in the comment box yes, and given is written, so that I will proceed further. Put in the comment box yes. Okay. So let us see first what are the different steps that we will use. So very first we require the diameter. So very first I will calculate MT. For MT, after further calculation, we require diameters also of all the gears in order to calculate the PT. Therefore, in the initial stage only, I will calculate the diameters. Basically, so I can calculate here D dash or D. I will say A, then DB and DC. I can easily calculate these three. Module is given EM into ZA, EM into ZB, and EM into ZC. So these are I am giving you the steps. So this is the basic calculation. Then I will move for step number 1. Here only 2-3 steps are there. So torque acting on this gear. So I will say MT A is equal to, we are having 60 into 10 raised to 6 kilowatt divided by 2 pi ENA. ENA is given, power is given, you can easily calculate MTA. Now, as the gear B is idler gear, whatever power it will take from A, it will give to C. It is not transmitting to any of its shaft. We are not taking any output from B. So we can say by writing this sentence, I will say that MTB as it is idler 0. Then whatever it will take, it is transferring to C. Therefore, I will calculate further EMTC. So what is the power it is taking from A? It is transferring to C. What is the power it is taking from gear A? It is transferring to C. So I can say that power A is equal to power at C. So I will write the formula for power for A. I will give in detail somewhat what power it will take it. Just numericals. Again, we will be writing in detail. So I will write here 2 pi n A into MTA divided by 60 into 10 raised to 6 is equal to 2 pi ENC into MTC divided by 16 to 10 raised to 6. All will get cancelled. You will get MTA NA is equal to MTC NC. We are having NA value and NC values. You will easily get the value of MTC. This is our torque calculation. Step number 1 over. Now, component of gear tooth forces. Step number 2, I will say components of gear tooth forces. So I can easily calculate between A and B. I am saying therefore PTAB is equal to twice MTA divided by DA. You can easily calculate, and PRAB is equal to PT into tan alpha. PTAB into tan of alpha. So you can easily calculate this also. As gear B is idler gear, whatever torque it receives from A, it is directly transmitting to C. Whatever torque receives from A, it is directly transmitting to C. So here I can conclude that as torque is same and radius is same. Directly I will say PTAB is equal to PTBC. This I will explain once again. Okay, so your component is over because you have calculated. Therefore, PRAB is equal to PRBC, component over. Then we will be going for drawing the free body diagram, and last we will calculate the reaction. So I will show you free body diagram by drawing only, and last is the reaction on the idler gear. I will show here RB we will calculate. So in this way we will proceed. So these are the some basic steps that I have given you. Now starting with very first, before proceeding for further, let us calculate the diameters. Just now what I have mentioned. So here I will write PCDs for gears A, B, C. So I can say here D dash A. You can say D also, D dash B, D dash C. I will say here M into ZA, M into ZB, M into ZC. Now you will substitute the values and we will calculate. Then I will go for step number 1. Torque acting on shaft A, B, and C. Okay, so now M into ZA, just substitute values. Module is given as 5 millimeters, ZA 30. So easily I can say 150 millimeters. Then module is given 5 and ZB here 60. So it will be 300 millimeter. And last case, module is 5. Number of teeth 40. You will get here 200 millimeters. So these are the prerequisite data. And then now we will move for step number 1. Now we have calculated diameters. Now step number 1. We have to calculate the torque acting on shaft A, B, C. So I will say here torque acting on A is equal to, we are having formula 60 into 10 raised to 6 divided by 2 pi 2 pi 2 pi NA. So substitute values here. I will say 60 into 10 raised to 6. Here kilowatt is remaining. Kilowatt. So 60 into 10 raised to 6 into 3.5 power to be transmitted is given divided by 2 pi into Na is given as 700. So now EMT A, you will get answer in Newton millimeters. Tell me the answer. Now what is the answer? Let me know. After substituting all the values, you will get the torque transmitted by 47746. Okay, very good. 0.48. 47. So I will write down here 47,746.48 Newton millimeter. So this is the your value for torque transmitted. Very good by A. Now gear B is idler gear. So I will write down here. Gear B is the idler gear and does not transmit any torque to its shaft. Whatever torque it is taking from A, it is as it is giving to C. But we have driver shaft, means it is connected to shaft. So it is taking from shaft driver at A and it is delivered at C. So there is no shaft or no output taken at B. Therefore, here we can say here that MT for B is equal to 0. Now, next, same power is transmitted. So I will say as the same power is transmitted from gear A to gear C, and the same power is transmitted from gear A to gear C. Okay. So what I have mentioned here, KWA is equal to KWC. So if you put the formulas, what I have mentioned already here in the first slide. So 2 pi Na and N, sorry, 2 pi. So what I will say here, this 2 pi same, 16 to 10 raised same, 2 pi same, 16 to 10 raised to 6 same. So this is nothing but what I have written in the steps only. Kilowatt for A is equal to kilowatt for C. So what it will become? NAMTA is equal to NCMTC. So same I will write here without going for repetition. So we will take help and we will proceed here whatever we have written in steps. So I will mention here MTA, this is torque into NA is equal to MTC into NC. So now I can easily calculate here MTC is equal to MTA into Na by Nc. So substitute the values. 746.48 into Na 40 divided by 30. Here you will get the answer. Torque transmitted by gear C is equal to, and that too in Newton millimeter. So calculate answer and let me know. Hello. 63661. Okay, 63661.98. So I will say here 66, sorry. So 63661.98. And Newton millimeter. So this is the second one, Newton millimeter, and this is MTB is equal to 0. So this is step number 1 we have completed, torque transmitted. Now let us move to next step, components of gear tooth forces. So I will say here step number 2. Components of gear tooth forces. Now I will say it is between A and B and B and C. So I will say here the components of gear tooth forces. Between gear A and B are given by so I will say PT AB is equal to twice MT torque at A divided by T dash A is equal to 2 into 47746.48 bracket complete divided by diameter of A gear PCD 150. So you will get answer PT for, that is tangential force between A and B is equal to PTAB. Just substitute values, you will get answer as tell me answer. PT is equal to, you will get, okay, 61, okay, 636.62. 619, I will say 62, it will be in Newton. And then I will say the radius component. we have discussed in force analysis is given by PT tan alpha. So PTAB into tan alpha. So I will put here 636.62 into tan 20. So you will get the radial component PR AB is equal to, in Newton you will get the answer. What is the answer? Okay. 231.71. Good. So this is your value for PT between A and B. This is your value for PR. Now gear B is idler gear. So I will write here as gear B is idler gear. Whatever torque it receives from gear A is transmitted to gear C. So I will write here PTAB into dB by 2 is equal to here PTBC into also dB by 2. So I will take help of this diagram. If I will consider this, so here, if I will consider gear B, then what torque it will receive from gear A? It is that it is transmitting here. So for example, I will say this is PTAB. So PTAB into this will be dB by 2 is equal to whatever this side it will be there. So I will show direction. This will be in clockwise. So I will show here anti-clockwise, and as this is in anti-clockwise, so clockwise. So here direction. I will go for separately direction. So PT BC. So the torque for B is given from this side PTAB, tangential force into dB by 2. If I take this force, then PTBC into dB by 2. So as dB get cancelling. So here we can clear cut say that it is nothing but PTAB is equal to PTBC, and therefore PRAB is equal to PRBC. As PT is same, PR will also be same. So I will mention values also. 636.62 Newton and 231.71 Newton. So this is the value for PT calculation and PR calculation. Step number 2 over. Now I will mention somewhat here step number 3, and I will take help of next slide also. Step number 3. So here I can say it as free body diagrams. So very important concept. So what we have discussed in the analysis? Just one line I will highlight. Tangential component. Tangential component PT always in the direction of rotation. That is this I am writing for driven, and opposite to that for driver. And PR, it is always directed toward the center. So it is always directed towards center of gear. Therefore, this is also called as separating forces. So now let us go for the construction of free body diagrams. So very important consideration. So let us take first all the gears, then we will proceed for the diagrams actually. Okay, just wait. I will draw first the three circles, then we will proceed. So this is the first gear I will say. Then I will go for drawing the second one. So this is the second one. And now let us go for third case. So this is the third one. And now let us go for showing the what we can say the actual. So it will take taking some time for drawing. Yes, okay. So this is third one. So now let us show the actual components that how. Okay. So now we will go by detail. First one, gear A we will show, then gear B and gear C. So in the diagram it is given. I will take this as the center point, and it is mentioned here something like this. This is fixed, and this is gear A, and it is rotating in this direction. Okay. So now this is gear B, and I will show here. This is gear C. This is nothing but the gear C, driven gear. So now I will compare only for gear 1 and gear A and gear B. So if I assume here in this case, so here if I assume like this, it is continuing up to this side also gear. So I will show in this case up to center point, and on this side also I will show. So in this you have to show some first markings. So I will now give the directions. So what we have seen, it is rotating in clockwise direction. So gear B, it will rotate. So here immediately you have to give the direction for this. So it is rotating in clockwise. So gear B, it will rotate in this direction. So if here this is point of contact, I will say, then PT will be in this direction. It will always in the direction of rotation. And for this case, it is opposite direction. So I will say this is the direction for PT. I will say here point number 1 and point number 2. This is between the two cases. Then the PR is always directed toward the center. So I will say this is PR acting on this gear, and this is the PR acting on this gear. And then further I can connect this as now similar case I can show on this another side. Okay. So once again I will repeat PT, tangential component for driven. Now I will case gear A and gear B only. So in main case, gear A is the driver and gear C is driven. But now for these two pairs, I will say A is the driver and B is driven. So the tangential component always in the direction of rotation. So PT is, I have shown like this, and PT for gear A in the opposite direction, and PR for both the cases, it will be in the directed toward the center. Now, if I say that B and C, consider pair B and C. So now B is rotating in anti-clockwise direction. B is rotating in anti-clockwise direction. So B is rotating in this direction. So definitely A will rotate, C will rotate in clockwise direction. So I will say here, this is the direction of rotation. Okay. So now if I say this is the contact point, then PT for this as it is rotating in the direction. So PT will be like this. And in the same case, if I say for this, the PT will be opposite. So this will be PT if I compare pair BC. And now the radial component for both the gears acting toward the center. So this is nothing but PT. So I have shown PR PT. This is the free body diagram. And now the angle between this is 90 degree. Okay. So this is the free body diagram between A, B and BC. I will consider give this name point as point number 3 and point number 4. Once again, I will repeat. This is rotating in clockwise direction. Therefore, this will rotate in anti-clockwise direction. The PT which I have shown at this point, point number 2, is in the direction of rotation. Therefore, I have shown like this. And this PT is opposite to that. PR for both the cases is directed toward the center. This is the force analysis between A and B. Now let us consider between B and C. For B and C, B is the driver and C is the driven. So B is rotating in anti-clockwise direction. Okay, then C will rotate in clockwise direction. Therefore, PT will be in the direction of rotation at point 4. Therefore, PT I have shown, and at point 3 I have shown opposite to it. And PR at 3 and 4 point it is directed toward the center. So this is the free body diagram which we have considered. And now before proceeding further, that is a reaction at the idler gear, I want to highlight here some points. So if I consider here at particular this point, what are the loads acting? So at particular this point, if I consider, so at this point, if I consider, then in this direction, the load is acting PR plus PT take parallel. So this PR and this PT I am taking. So it will be act in this direction at point B. and from this direction it will act as like this, and this is nothing but your this PR and this PT. So here I can say this load is acting as PR plus PT. This also load is acting as PR plus PT at the center. But I don't want loads. I want reaction. So reactions, these are the opposite forces to load from bottom side. So what we have to calculate? We have to calculate nothing but the reaction. So this is one reaction. This is another reaction. This reaction will having the dimension PR plus PT. This also having the dimension PR plus PT. Okay. So let us complete. And what we have to calculate? We have to calculate the reaction, nothing but what we have to calculate? We have to calculate the reaction at this particular point. So I will say this point reaction as RB. So RB is nothing but under root of PT plus PR square plus PT plus PR square. So this I want to explain by using this diagram, and then we will proceed further. So last step I will write down. Reaction at the idler gear shaft. Reaction at the idler gear shaft. So if we consider the equilibrium of forces at this particular point, then two phases are at 45 degrees, means 90 degrees there at point 2 and 3. So if I consider the load at point at the center of the shaft will be PT plus PR and PT plus PR. So the reactions will be same. So these are two reactions, and these reactions I have shown PR plus PT, PR plus PT, and the net reaction on the idler shaft is given by. So I will say here RB is equal to nothing but under root of PR plus PT bracket square plus PR plus PT bracket square. So just 2 times it is, so substitute the value under root of 636.62 plus 231.71 and this bracket square. Okay, so let me know what is the value of RB. This you will get answer in Newton. RB value in Newton. Calculate fast. PT plus PR square, PT plus PR square. So 2 times PT plus PR square. If you substitute the value and making square root, you will get the answer as, what is the answer? Answer for RB 1228.00. Okay, so I will round up 0.00. I will not take. I will say 1228. So in this numerical, this is the problem given, and we have gone for first calculation of the piece circle diameters, then torque acting on the shaft MTA, idler gear MTB and MTC. Then we have calculated the components of gear tooth forces PTAB. Between A and B we have calculated. Then we have discussed about how to calculate between B and C and how it is same, that also we have discussed. Then we have gone for the free body diagrams, and the free body diagrams for the gears are as shown in this figure. So here you can see the free body diagram for this So between gear A and B, the reaction PRPT and shown. Between gear B and C, the components PRPT and shown. The directions, how to take the directions, it is also explained. And how the reaction will act at the shaft B, idler gear shaft, that also calculated. And this is the final answer for the reaction.